right, number 32. This one already has a little chart set up for you, so I would maybe just skip ahead and look for the variables. And we're asked how many of each type of bolt should be manufactured to maximize revenue. Right, so your bolts are the X and the Y. Right, and we've got type A and type B in that chart. And then you've got 3 different machines. All right, and all of this is already given to you, the number of minutes that each bolt needs on each machine for production. 0.5. Okay, and then you have, let's see. All right, and then you have constraints on the number of minutes available on the machines. So you can see why we need this chart. We're putting some constraints on machine 1, 2, and 3. All right, and so we need to stay below those minutes that are available, 240, 720, and 160 respectively. So I think maybe the hint that I'll give for this one would be when you're graphing these inequalities, if you don't like these decimals, you can change this. So for instance, for the first constraint, I could write, let's go back, always put your X's and Y's, since we'll be making more than one bolt. So your first constraint could be 0.1 X plus 0.1 Y is less than or equal to 240, or I could multiply everything by the same number, and I could do 1X, 1Y multiplying by 10, and then on the right I'd have 2,400. Right, so if you don't like decimals, that's fine, and then you'll probably just have a larger scale on your graph, since your numbers on the right will then be larger. All right, so see what you can do with that. All right, number 33. This one is not one that needs a chart. Okay, so we've got gallons of gasoline and gallons of fuel. Okay, and let's see, we're trying to maximize revenue, so that's your objective function. All right, so look for the revenue for gasoline and the revenue for fuel. And then for your constraints, the first one that's mentioned is that the oil refineries manufacture at least 2 gallons of gas for every gallon of fuel. All right, so it's kind of like 2X for every 1Y. All right, so one constraint that would be kind of obvious to write here, it almost looks like this is going to be 2X is greater than or equal to Y. All right, so let's check this out. What if it was exactly 2 gallons of gas for each gallon of fuel? So then we'd have 2X equals Y. All right, so let's check some values. If X is, for example, 4, then Y would have to be 8. All right, based on the equation that we've written here. All right, so that's saying that for every 4 gallons of gas, we'd have 8 gallons of fuel. Right, and that's actually the exact opposite of what we want. We want the ratio to be 2 to 1, not 1 to 2. Not 1 to 2. All right, so in this case, we actually want the 2 over with the Y. We actually need 2 Y's to make up every X. We've got way more X than we have Y. All right, so in this case we would do, this is wrong. All right, we want X is greater than or equal to 2Y. Right? And then let's check at least one other number. So if it's at least 2 gallons of gas, then that means we could have more than that. We could have maybe 3 gallons of gas for 1 gallon of fuel oil. Right, so if we check that in the inequality, X is greater than or equal to 2Y, then we'd have 3 is greater than or equal to 2 times 1, and that does work. All right, so if you're not sure how to write these constraints, you could always look at that boundary line and kind of go from there. All right, okay, that should be good for number 33.